Yeah. Good evening, children. Good evening. Good evening, online children.
Good evening, ma'am.
Good evening.
Good evening.
Yeah. Good evening, children. So today we are taking up a new chapter, quadratic equations. To get started with the word problems on quadratic equations, we don't need any introduction to the chapter because you already know how to solve a quadratic equation by splitting the middle term and also by using the quadratic formula. We have been introduced to the quadratic formula in the class here sometime earlier. You might have learned it in school also. So to solve word problems from this chapter, quadratic equations, you just need to know how to construct the equation from the situation given and solve the equation by splitting the middle term or by using the quadratic formula. To deal with the rest of the chapter, we need to, recall or learn some concepts. So recall if you've already learned in school. Otherwise, I need to introduce some concepts to you to, work the rest of the chapter. Word problems part, we can do it just with the knowledge of splitting the middle term and how to use the quadratic formula. All right. So I'll just directly get started with this. An aeroplane left 50 minutes later than its scheduled time. And in order to reach the destination 1,250 kilometers away in time, it had to increase its speed by 250 kilometers per hour from its usual speed. Find its usual speed. So we do not know the usual speed of the aeroplane. So let it be x kilometers per hour. The usual speed of the aeroplane is not given. So let it be x kilometer per hour. The new speed is x plus 250 kilometers per hour. The new speed is x plus 250 kilometers per hour because it had to increase its speed by 250 kilometers per hour. So let the usual speed of the aircraft be x kilometers per hour. Then the new speed is x plus 250 kilometers per hour. Now the distance is 1,250 kilometers. Now distance will not change. The distance between the two places will be the same. It's only speed and time that are, the variables. So they are inversely proportional, speed and time. If you increase your speed, less time taken. Speed is reduced, time taken is more. So speed and time are inversely proportional. They are the variable factors. The distance between the two places is fixed. So distance is 1,250 kilometers. Usual speed x kilometers per hour. New speed x plus 250 kilometers per hour. So now we have to work on what is the actual time taken and what is the new time taken. See, these are the three factors, right? Which go together: speed, distance, and time. These are the three things that go together: speed, distance, and time. Speed, we know the two speeds, x and x plus 250. Distance, there's nothing like original distance, new distance. There's nothing like that. So distance is 1,250 kilometers in both the cases. But time, we have original time taken and new time taken. Correct? For every, okay. So we have original speed and new speed. X plus 250. Okay. Distance is distance, 1,250 kilometers. Time, we have original time taken and new time taken. Okay, because speeds are different, time taken will be different. So how do you find the time taken? Time taken is equal to the formula. We know speed is equal to distance by time. So time is equal to distance by speed. Time is equal to distance by speed. Okay, so the original or the actual time taken, the usual time taken is the distance 1,250 by the usual speed, x kilometers per hour. The new, this is the old time taken. Now the new time taken is the same distance by the new speed, x plus 250. Now the unit is hours. The unit is hours. So the original time taken is distance by speed, 1,250 by x, hours. And the new time taken is distance by speed, 1250 by the new speed, x plus 250 hours. Now, we know when speed is more, the time taken is less. So here the time taken is less. This is less time. This is less time taken. Here the speed is less, no? So the time taken is more here. The time taken, see, where is the speed? When you compare the speeds x and x plus 250, here the speed is less. When you compare the speeds x and x plus 250, here the speed is less. So the time taken is more here. The time taken, the value of 1250 by x is more here. What is 1250 by x? It's the value of time here in hours. It's the value of time here in hours. This value is more because the speed is less. This fraction represents the time taken. Okay, and the value of this fraction is more than the value of this fraction. Okay, so coming to this, what's the speed here? X plus 250. Relatively, the speed is more here. So the time taken is less. And what is time taken? This fraction represents the time taken. And that fraction is less than this fraction. The value of this fraction is less than the value of this fraction. The two fractions represent the time taken. The two fractions represent the time taken. Here the speed is less. So this fraction represents more time. This speed is more. So this fraction represents less time. Now, how are we going to construct the equation? The difference in time taken is 15 minutes. The difference in time taken is 15 minutes. Let's understand this. What happens is, though the aircraft, takes off 50 minutes later than the scheduled time, it starts late, still it reaches the destination on time. That means the difference in the time taken is 15 minutes. Let's see that again. The aircraft does not take off at the scheduled time. It leaves 50 minutes later. Okay, it leaves 50 minutes late, but it reaches the destination on time. It reaches the destination on time. Now, supposing the travel duration, the usual travel duration is say 2 to 5, 3 hours. The usual travel duration is 3 hours, okay, 2 to 5. It's supposed to take off at 2, but no, on that particular day, it does not take off at 2. It takes off at 2:50, but it reaches at 5 o'clock. It reaches at 5. So the difference in the time, here it's taking 3 hours, no, but here it's taking only 2 hours and 10 minutes. So what is the difference in time taken? 50 minutes. The difference in time taken is 50 minutes. So say it usually starts at 2, it takes off at 2 and lands at 5. The total time needed is 3 hours. But on that particular day, it takes off 50 minutes later. So it takes off at 2:50. 2:50. Okay, but it reaches at 5. So then how long was the aircraft in air? How long was it flying? Only for 2 hours, 10 minutes. As against 3 hours, which it usually takes, 3 hours. It takes only 2 hours, 10 minutes. So the difference in time taken is 50 minutes. So this is the equation you have to have in words. The difference in time taken is 50 minutes. The difference in time taken is 50 minutes. Is the equation in words. You should, whenever you're solving a word problem, you need to construct the equation in words first. You need to construct read the situation and construct the equation in words. And then convert that equation in words to a mathematical equation by substituting the relevant expressions. Okay, so we've constructed the equation in words. The equation in words is difference in time taken. Difference in time taken. Don't write anything. Difference in time taken is equal to 50 minutes or 50 by 60 hours. Okay, so how do you write the difference in time taken? Now, it actually takes 3 hours, but it takes only 2 hours and 10 minutes. This difference is only 50 minutes, right? So that means where it takes more time minus where it takes less time is equal to 50 minutes. More time taken minus less time taken is equal to 50 minutes. Difference in time taken is 50. So we have two expressions, no, for time, old time taken, new time taken. We have two expressions for time. Where is the value of time more? Here. Here the value of time is less because speed is less here. So the value of time is more here. So this more time taken minus less time taken is equal to 50 by 60 is the equation. That means 1250 by x minus 1250 by x plus 250 is equal to 50 minutes or 50 by 60. So what's the actual speed? X kilometers per hour. What's the new speed? X plus 250 kilometers per hour. Distance is fixed. Time taken, original time taken is equal to distance by original speed. New time taken is equal to distance by new speed. Here the speed is more, so time taken is less. Meaning here the speed is lesser. When you compare the speed x and x plus 250, here the speed is less. So time taken is more here. So here it's taking 3 hours. But here it takes only 2 hours and 10 minutes because it increased its speed, no? So it's reaching the destination in less time, 2 hours, 10 minutes. So the equation we constructed in words is the difference in time taken. Difference in time taken is equal to 50 minutes. Difference in time taken is equal to 50 minutes or 50 by 60 hours. 5 by 6 hours. So difference is more time taken. That is 1250 by x minus less time taken here is equal to 5 by 6. So we need to solve this equation and find the value of x. All right? Yeah. Write down. Please take down the question and go through the slide, or as you work, you can just understand. Start working. Online children, I didn't check this. I've shared my screen. Visible, right? From the beginning?
Yes, ma'am.
Yes, ma'am.
Okay. All right, children. second. So the situation is like, say you start to school at 8 o'clock in the morning and you go cycling to school and you reach school at 8:30. On a particular day, you leave home at 8:20. You have to reach school at 8:30, right? So you cycle faster and you reach school at 8:30. You safely cycle faster and you reach your school. You're not able to enjoy the nature that day. Otherwise, you are like, like singing song to yourself and you're enjoying the nature. You're cycling early morning, fresh air. So you take half an hour. You go with very less, you cycle at very slow pace, less speed, you enjoy nature and hum some music, you're enjoying your cycle ride to school. But on a particular day, you get ready late, so you step out at 8:20. Still, you have to make it to school at 8:30, right? Right? So what's the difference in the time taken? 20 minutes. You normally take 30 minutes. Here you've taken only 10 minutes. You normally take 30 minutes. But see, on this particular day, you took only 10 minutes. So the difference in time taken is 20 minutes. That is what is given here. See, you left 20 minutes late, no? You're supposed to step out at 8 o'clock, but on that day, you stepped out at 8:20. So you started 20 minutes later. You're supposed to leave at 8, but you left at 8:20. So you left 20 minutes later than the scheduled time. That's what is here. An airplane left 50 minutes later than its scheduled time. Like you left the school on this particular day 20 minutes later than the scheduled time. But you still you still reach school on time. So that means the difference in time taken is 20 minutes here. That's what we've written here. The difference in time taken is 15 minutes. That's the equation in words. The difference in time taken is 15 minutes. And what is different? Something minus something. More. So the usual time taken minus the new time taken is equal to 5/6. So then substitute. What is the usual time taken? This one. New time taken, this one, is equal to 5/6. Then what do you do ahead? 1,250 is common in the numerator. So take out 1,250 common. Then in the bracket you have 1/x. In the bracket you have 1/x and 1/x plus 250 is equal to 5/6. Right? Then LCM, common denominator, x into x plus 250. Then this goes here, right? Okay, is equal to 5/6. Now x and x gets cancelled. X plus x minus x cancels. All right, so we have 250. So 1250 into 250 by x squared plus 250x is equal to 5/6. Now what I have done is, there are numbers here and there. So I got all the numbers to one side and I took the x square and x to the other side. This is 1250, this one 5/6. So I got x square and x on one side and I took all the numbers to the other side. So like cross multiplying, what happens? This one comes here, no? This is in the denominator. This expression is in the denominator. So I'll go to the numerator on the other side. So you see here, it's come up. And this 5/6, when it comes to the other side, it becomes 6/5. So already on the left-hand side, we have this number and we have this number. They are already there on the left-hand side. Now, who's coming to the left-hand side? 5/6. So it will come to the left-hand side. From the RHS, it comes to the LHS as 6/5. These two people are already here. So no change. This one is coming to the other side as 6/5. And this one is in the denominator, on the other side, numerator. Then cancel and all that, and this is the equation. Multiply, and this is the equation. Now it's pretty large to split the middle term. So use the quadratic formula. So you know the value of A is 1, B is 250, and C is minus 3,75,000. And find the discriminant, B square minus 4AC. Then the formula is x is equal to minus B plus or minus root D by 2A. 2A. What is A? 1. So 2A meaning 2 into 1, which is 2. Now this you should know the long division. Okay. 156250. 156250. Okay, so group in twos from behind. 3 is a 9. 6 is the remainder. 62 comes down. Double the quotient. 6. Whatever you add here, you should add the same thing here. So what's happening? 156,250. 156,250. I didn't group it correctly. What am I seeing here? 1250. For 00, there's a mistake. That's what I'm wondering. 1562500. Did you note that? 1562500 it is. That's what I'm wondering, because I'm getting a 3 first, and here it's 1250. While typing, I missed to type 10, children. So my grouping is, see, nobody could make out that mistake. Okay, so so that means it's very clear that nobody has found the square root of the number, but has just taken down from the slide. So group the digits from behind. 1 stands alone. 1 into 1, 1, 0. Bring the next pair down. Double the quotient. 1 into 2, 2. Whatever digit you place here, you must place the same thing here. So 2, 2. 22 into 2. 22 into 2, 44. So 44. Subtract 12. Bring the next pair down. Double the quotient. 12 into 2, 24. Whatever digit you place here, you must place the same digit here. So 2, 4. If you place a 5 here, you should place a 5 here also. So 245 into 5. 5 has a 25, 2 carried over, 2 carried over, 12. So 5, 5. 0 is a remainder. The next pair comes down. Double the quotient. 125 into 2, 250. Whatever you add here, you should add the same thing here, but it's 0. So it is 0, 0. So it is 2500 into 0, which is 0. So don't have to continue. That's it. Close the division. So the square root of this number is 1250. So it's very important to know how to find the square root of a number by the long division method. Mostly here, the numbers under the square root will be a perfect square in most cases. Okay. So plus or minus, right? So we have two cases. One with plus, the other with minus. 500 and minus 750. We get two values for x. X is 500, x is minus 750. And what is x here? Speed of the aircraft, which cannot be negative. So x is equal to 500 kilometers per hour. So the usual speed of the airplane is 500 kilometers per hour. All right. Okay. The time taken by a person to cover 150 kilometers was 2.5 hours more than the time taken in the return journey. So there's this person who walks 150 kilometers and returns. He comes back the same distance, 150 kilometers. The time taken by a person to cover 150 kilometers was 2.5 hours more than the time taken in the return journey. So this person walks or whatever he does, he covers 150 kilometers. Then he returns 150 kilometers. While returning, he increases his speed. Because while going, he takes 2.5 hours more. The time taken to go is 2.5 hours more than the time taken to return. So supposing the time taken to reach, okay, supposing the two places are A and B. A to B, the distance is 150 kilometers. So he starts from A and he covers this distance to be 150 kilometers, say in 10 hours. Return journey, he covers the same distance in 7.5 hours. Okay. The time taken by a person to cover 150 kilometers was 2.5 hours more than the time taken in the return journey. If he returned at a speed of 10 kilometers, if he returned at a speed of 10 kilometers per hour, more than the speed of going, if he returned at a speed of 10 kilometers per hour, more, not 10 kilometers per hour, 10 kilometers per hour more than the speed of going. So return journey speed is more, that's why time taken is less. Return journey speed is more, that's why time taken is less. Where is the time taken more? Onward journey or return journey? Onward journey or return journey? Onward is going like this. Return is you're coming back. Okay. Where is the time taken more? Onward journey or return journey? Onward journey. Onward journey, the time taken is more. He takes 2.5 hours more than the time he takes during the return journey. So if the time taken is more in the onward journey, the speed is less there. The speed is more in the return journey. The speed is more in the return journey. That's why it takes less time there. Okay, so the speed, return journey speed is 10 kilometers per hour more than the speed of going. What was the speed per hour in each direction? What was the speed per hour in each direction? Okay, so onward journey, return journey. All right, onward journey, speed x, speed x plus 10 kilometers per hour. Distance is fixed. Distance is 150 kilometers here, 150 kilometers here also. Time taken, distance by speed. Time taken is distance by speed. What's the distance? 150. What's the speed? X. What's the distance? 150. What's the time? X plus 10. I'm sorry. What's the speed? X plus 10. And here also the difference in time taken is 2.5 hours. The difference in time taken. Okay, onward journey, he takes 12.5 hours. Return journey, he takes only 10 hours. Onward journey, he takes 12.5 hours. Return journey, he takes only 10 hours. So the difference in time taken is 2.5 hours. That's what is given in the question. So we have to construct the equation in words. The difference in time taken is 2.5 hours. Onward journey, he takes, for example, 12.5 hours. Return journey, he takes only 10 hours. So the difference in time taken is 2.5 hours. Where does he take more time? Onward journey. Where does he take less time? Return journey. Where does he take more time? Onward journey. Less time? Return journey. So return journey, less time, so more speed. Onward journey, more time, so less speed there. Where time is more, speed is less. Difference in time taken. Difference in time taken is 2.5 hours or 5/2. It's 5/2. So more time taken minus less time taken is equal to 5/2. More time taken is in the onward journey. Less time taken is in the return journey. So onward journey, what's the time taken? 150 by x. This is the time taken. This expression represents time taken minus time taken in the return journey. 150 by is equal to 5, right? You see it again, see here. Let the onward journey speed be x kilometers per hour. Distance 150 kilometers. Time taken, distance by speed. Distance by speed. So this is a time taken. let the speed of the return journey be x plus 10 because it's given here. It's given here. He returned at a speed of 10 kilometers per hour more. So return journey speed is x plus 10 kilometers per hour. Distance same. Time taken, distance by speed, 150 by x plus 10. So we are done with the assumptions. We are done with the assumptions. Now the equation. After the assumptions is the equation. Equation is difference in time taken is 2.5 hours. So more time taken. So time taken during the onward journey minus the time taken during the return journey is equal to 2.5. So I'm not taking, see, I've taken this 2.5 is 25 by 10, right? Then 5 by 2 I've written. Okay, then 150 common. So working is the same as earlier, similar to the earlier one. You can complete this. So here I've just split the middle term because the numbers are simpler. Yeah, one is negative, the other is positive. So let go the negative value, take the positive value. Yeah, please work. Completed? Okay, so like the earlier one, take out 150 common. So you get 1 by x minus 1 by x plus 10. And here this is 5 by 2. You can directly write 2.5 as 5 by 2 also. I've made it 25 by 10 and then cancelled it and got 5 by 2. Common denominators, I've multiplied x into x, x square plus 10x. You understand that? LCM, x into x, x square plus 10x. That's the LCM. So this goes here, this goes here. X plus 10 minus x is equal to 5 by 2. Plus x minus x cancels. And here you have 150, you have this 10, and this 5 by 2 becomes 2 by 5 here. And when you cross multiply, this goes to the numerator, x squared plus 10x. Now 5 and the 5 twos are, so this is what 600. On this side, this one is 600. This is 600. So what is this? 600 is equal to x squared plus 10x, or x squared plus 10x is equal to 600. You can write it that way also, no? 600 is equal to x squared plus 10x, or x squared plus 10x is equal to 600. So when you bring the 600 to this side, it will be x squared plus 10x minus 600 is equal to 0. 600 is equal to x squared plus 10x. See the other way. X squared plus 10x is equal to 600. So x squared plus 10x plus 600 comes to the other side as minus 600 is equal to 0. This one is 600. So you can write it as x squared plus 10x is equal to 600. So x squared plus 10x minus 600 is equal to 0. Split the middle term. Minus 30, 20, not possible. So x is 20. X is 20. So this 20 plus 10, 30. Onward is 20, return is 30. All right. Okay. You're not well, Bhavishya? You're not well? Headache, huh? Tired. This is over? Okay. It's quite simple. We'll do this later. Yeah. 1 minute. I'll just select the sums. Yeah, we'll do this one. We'll do everything, but look at this one. The diagonal of a rectangular field is 60 meters more than the shorter side. Rectangular field. Okay, rectangular field. Diagonal. Okay, diagonal. Okay, the diagonal of a rectangular field, let me call it D, is means equal to, is 60 meters more than, 60 meters more than the shorter side. So what we have read there, we're just writing it as a simple equation. Write it again. Diagonal is 60 more than the shorter side. I've told you whatever comes 60 more than what? Whatever comes after than should be written first. I've told you that. Whatever comes after more than, less than, that should come first. After more than, less than. So here after more than, what you have? Shorter side. That should be written first. So S plus 60 it is. It is not 60 plus S. 60 meters more than, what is after than? Shorter side. That you should write first. So S plus 60. If the longer side is 30 meters more than, after more than what you see, shorter side. So that will come first. 30 meters more than. Okay, find the sides of the field. That is, find the length and the breadth of the field. You understand this? Okay, so when you read, whenever possible, read the information and convert it to mathematical equations like this. This becomes easier to assume. So now we know this, right? So you can call anything as x, children. There is nothing like you should take the diagonal as x. See, normally we take, one of this. So what are the three things here? Diagonal, longer side, shorter side, diagonal. These are the three things. The three things here are longer side, shorter side, diagonal. Longer side and shorter side are the sides of the rectangle, length and breadth. Longer side, shorter side, they represent the length and the breadth of the rectangle, and then diagonal. So there are three things. And we know that we can connect these three things by Pythagoras theorem. Okay, so that's how we're going to construct the equation. How? Because in this question, we have information only for assumption. For equation, we don't have anything. To construct the equation, there is no information here. So that means there is a default condition. And that is Pythagoras theorem. Pythagoras theorem will connect all these three. It will connect the length, breadth, and the diagonal. So you assume anything as x. After writing this, okay, I'll tell you again. In this question, we have information sufficient to assume. We don't have an information to construct the equation. Then how are we going to construct the equation? In this figure, the length, breadth, and diagonal can be connected through an equation using Pythagoras theorem. So we know that the length square plus breadth square is equal to diagonal square. So we know this. So this is how we want to construct the equation. So now is the assumption. Who is x? Anybody can be x. Supposing you call the diagonal as x. Supposing you call the diagonal as x. Okay, diagonal is x. No, this is x. Then what is the shorter side? Shorter side. Listen very carefully. This is x, right? So then what is s? X minus 16. What is s? See, d is equal to x. Now you should fill s and l, shorter side and longer side. You have taken diagonal as x. So see, I've slashed it and I've written x there. Okay. Then what is s? Transpose and tell me, what is s? X minus 60. Transpose. S is equal to x minus 60. Then what is L? What is L? What is S? X minus 60. No, this is x minus 60. So L will be x minus 60 plus 30. That means x minus 30. Let the diagonal be x. So diagonal is x. So now we have to write the shorter side and longer side in terms of x, using x. So shorter side will be x minus 60. Finished. Now longer side. Longer side is s plus 30. What is this? X minus 60. X minus 60 plus 30. So x minus 30. Now supposing you call the shorter side as x. Okay. Supposing you say let the shorter side be x. Let the shorter side be x. Then what's the diagonal and the longer side? Diagonal is equal to x plus 60. We can see there only it's x plus 60. Then what's the longer side? Shorter side is x. Shorter side is x. X plus 30. The longer side is x plus 30. So like this. Now supposing you assume the longer side as x. If you assume the longer side as x, longer side is x. The longer side is x. Then we have to write the expressions for the shorter side and the diagonal in terms of x. So longer side is x. So what is s? S is equal to x minus 30. See here, s, shorter side s is equal to x minus 30. S is equal to x minus 30. Transpose. S is equal to x minus 30. Then what's the diagonal? Diagonal, it's s plus 60. What is s? X minus 30. S is x minus 30. So x minus 30 plus 60. So x plus 30. X plus 30. So you can assume anything as x. So do this in the rough column. Do this one. This one you can show it in the main working also. Okay, so that you can decide. So please write the information like whatever you read, convert it to mathematical equations like this, and then take somebody as x and find the others in terms of x. So here the three people or the three characters are length, breadth, and diagonal. Call anybody as x and find the others in terms of x. And that becomes easy when you write like this. And as we understood, all the information in the question we have used only to assume. Now, what is the equation? Equation is using Pythagoras theorem. Yeah, please work. So how do we expand x plus 30 the whole square? A square plus 2ab plus b square. A square plus 2ab plus b square. Don't forget 2ab. Here also x plus 60 the whole square. A square plus 2ab plus b square. X square on either side gets cancelled. Okay, then this is the equation. I split the middle term. Negative value not possible. X is 90, which means the shorter side is 90, the diagonal is 150, and the longer side is 120. The diagonal is the hypotenuse, right? The diagonal is the hypotenuse. So hypotenuse square separately. You cannot add, you cannot write anything like this. You can't write x plus 60 the whole square plus x plus 30 the whole square is equal to x square. No, right? Yeah. Leg square plus leg square is equal to hypotenuse square. This is one leg. This is the other leg. This is the hypotenuse. These are the two legs of the right triangle. Right triangle. This is the hypotenuse. This is one leg. This is the other leg. Leg square plus leg square is equal to hypotenuse square. Completed? Online children? Completed online children? Okay.
Yes, ma'am.
All right. Yeah. uh, should I help you in at T minutes past 2 p.m. Abhina, T minutes past 2 p.m. Now it is 35 minutes past 8 p.m. Now it is 35 minutes past 8 p.m. Yeah, at the time 8:35. So it is 35 minutes past 8 p.m. 8 p.m. முடிஞ்சு எப்படி சொல்றது 8 p.m. முடிஞ்சு 35 minutes ஆயிடுச்சு. It's 35 minutes past 8 p.m. and it is 25 minutes to 9 p.m. Okay, now supposing that say now the time is 8:50. Now the time says 8:50. So what's the time in Keta? You can say it's 10 minutes to 9. It's 10 minutes to 9. Abhina, to 9 o'clock காமிக்கிறதுக்கு இன்னும் 10 minutes இருக்குன்னு. It is 10 minutes to 9 and it is 50 minutes past 8 p.m. So அந்த ரெண்டு consecutive hours வச்சு தான் நீங்க சொல்லணும் 8 p.m. 9 p.m. நீங்க 10 p.m. வராது 7 p.m. வராது ஏன்னா இப்போ டைம் 8:50 டைம் 8:50 with respect to 8 சொல்லலாம் with respect to 9 சொல்லலாம் 8:50 when the time is 8:50 you can talk with respect to 8 or 9 p.m. With respect to 8 p.m. you say it is 50 minutes past 8 p.m. With 9 p.m. you say it is 10 minutes to 9. So now this 50 minutes past 8 p.m. plus 10 minutes to 9 எப்பயுமே சேர்த்தா 60 minutes தான் வரும். நீங்க எந்த டைம் வேணாலும் எடுத்துக்கோங்க. சப்போசிங் இப்போ 8:20 ஆகுது. நான் சப்போசிங் த டைம் இஸ் 8:20 PM. நீங்க ரெண்டுத்தையும் சொல்லுங்க. 8 o'clock வச்சு சொல்லணும், 9 o'clock வச்சு சொல்லணும். இட் இஸ் 20 minutes past 8. இட் இஸ் 40 minutes to 9. ரெண்டும் சேர்த்தா 60 தான் வரும். Supposing it's 8:15. If it's 8:15 PM. With respect to 8, you say it is 15 minutes past 8 PM. With 9 PM, you say it's 45 minutes to 9 PM. So, rendu seta 60 minutes. So, this is how we construct the equation here. At 10 minutes past 2 PM, it's 2T, like 2:20, it's 2 PM, 2 hours and T minutes. At T minutes past 2 PM, the time needed by the minutes hand of a clock to show 3 PM, the next hour, was found to be 3 minutes less than T square by 4 minutes. Find T. So it is, we'll say the time with respect to 2 PM and 3 PM. So it is T minutes past 2 PM. And it is, and for the clock to show 3 PM, it was found to be 3 minutes less than T square by 4 minutes. So, it is, you need T square by 4 minus 3 minutes to 3 PM. It's T minutes past 2 PM. And how many minutes to 3 PM? T square here, and the time needed by the minutes hand of a clock to show 3 PM. For the clock to strike 3, every time we know. The time needed, see the words there, the time needed by the minutes hand of a clock. The time needed by the minutes hand of a clock to show 3 PM. And the minutes hand எவ்வளவு தூரம் travel பண்ணோம் 3 PM காமிக்கிறதுக்கு was found to be 3 minutes less than, நான் என்ன சொல்லிருக்கேன், whatever comes, நான் என்ன சொல்லிருக்கேன், whatever comes after less than, more than, that should be written first. So less than அப்புறம் என்ன இருக்கு, T square by 4, write that first. 3 minutes less, so T square by 4 minus 3. இன்னும் இவ்வளவு டைம் இருக்கு 3 o'clock ஆகிறதுக்கு. So T square by 4 minus 3 minutes to 3 PM. Now if you add these two, T plus T square by 4 minus 3, it's equal to 60 minutes. You must say minutes only. You should not write 1 hour. Because this is in minutes and this is also in minutes. So is equal to minutes. Minutes plus minutes is equal to minutes. So you read and understand. So this is all I can say. It is T minutes past 2 PM. And it is T square by 4 minus 3 minutes to 3 PM. And we have clearly understood that when you add these two, it will be equal to 60 minutes. This is in minutes, this is in minutes. Add both equal to 60 minutes. Whatever comes after more than, less than, write that first. And because it is less, you should say minus, not plus. And 3 minutes. So much time to 3 PM. Because it's given the minutes hand has to travel so much. The minutes hand has to travel so much to show 3 PM. So that means it is so many minutes to 3 PM. Yeah, please work. Yeah, I'll work it in detail here. So it's here, but take the question. I'll work the answer. Take the question. Yeah, solve this using the quadratic formula. Done, children? Finished? Yeah, what are the two values for t? 28. I don't think I have that answer. 14. Oh, yeah. Find t தான். t வேல்யூ தான் கேட்கிறேன். இல்ல நீங்க இதோட ஸ்டாப் பண்ணிட்டீங்களா? சால்வ் பண்ணலையா?
substitute in this way.
No,
Yes,
no,
ma'am.
no. உங்களுக்கு முடிச்சிட்டீங்கன்னா வேற ஆன்சர் வந்துருக்கீங்க என்னது b square minus 4ac b square minus 4 into a into by 2a பண்ணலையோ நீங்க t is equal to minus b plus or minus root d by 2a போடவே இல்லையே
By 48.
ஆ?
28 by 2.
ஆ. All right. Got all of you? 14 and minus 18. 14 and minus 18. Minus 18 not possible. T here is time, no? So not possible. So T is 14. The value of T is 14. T is minus 18 or T is equal to 14. So T is 14. So what's the time? It's 2:14. It's 2:14. So how many minutes to 3? 60 minus 14 is what? 46. It's 46 minutes to 3. It is 46 minutes to 3. So how is 46 expressed? T square by 4. What is T square? T is 14, no? T square, 196 by 4 minus 3. So 196 is 4 is 16, 39 minus 49. I said 39, but it's 14. Okay, so 4 4 are 16, 3 remains, 49 minus 3, 46. All right? 46. T square. It's now 2:14. So there are 46 minutes to 3. And that is what is T square by 4 minus 3. T square, 14 square, 196. By 4 minus 3. 49 minus 3, 46. Okay. Two trains leave a railway station at the same time. The first train travels due west and the second due north. So directions north, south, east, west. So one is traveling due west like this, the other due north like this. Okay, so the trains are this is north, this is west. I'll just call this O. Two trains leave a railway station at the same time. This is the railway station. They leave the station at the same time. So one train travels due west towards west, and the second one travels towards north. The first train travels 35 kilometers. Which is the first train? This is the first train. Because the first train travels towards west. That's the first train. This is the second train. The first train travels 35 kilometers per hour faster. The first one is 35 kilometers per hour faster. So let this be X. So this will be X plus 35. X plus 35 kilometers per hour. Okay, so we say let the speed of the second train be X kilometers per hour. So the speed of the first train is X plus 35 kilometers per hour, correct? If after 2 hours, they are 130 kilometers apart. See, in mathematics, distance is a straight line connecting the 2 points. In mathematics, distance is the straight line connecting the 2 points. So at the end of 2 hours, the first train reaches this point. At the end of 2 hours, the second train reaches this point. Now the distance between the two, okay, 1 minute, let me do it more clearly. Now what is O? The place, the station from where both the trains start. O. What is OW? OW is the distance covered by the first train in 2 hours. The line segment OW represents the distance covered by the first train in 2 hours. See, a line segment can represent only distance, not speed or time. You cannot say let O(n) be x. Line segment can only represent distance, not speed or time. OW is the distance covered by the first train in 2 hours. ON is the distance covered by the second train in 2 hours. So this is the position of the first train at the end of 2 hours. This is the position of the second train at the end of 2 hours or after 2 hours. And WN is the distance between the two trains after 2 hours, because distance is that straight line segment connecting the 2 points. Distance is a straight line segment connecting the 2 points. So they are 130 kilometers apart, which means WN is equal to 130 kilometers. So again, you can construct the equation using Pythagoras theorem. But what is OW? Distance. And how do you find distance? Speed into time. What is the speed? X plus 35. What's the time taken? 2 hours. This is OW. What is ON? Distance. What is distance? Speed into time. What is speed? X. What is time? Same 2 hours. So this line segment is 2x. This line segment is 2x plus 70. So this is 2x. This is 2x plus 70. So 2x the whole square plus 2x plus 70 the whole square is equal to 130 the whole square is the equation. Got it? See it quickly again. Station. This is the first train which goes towards west. Second train which goes towards north. How long do they travel? 2 hours. They travel for 2 hours. Where is at which point is the first train at the end of 2 hours? W. And where is the second train at the end of 2 hours? N. So what does the line segment OW represent? The line segment OW represents the distance covered by the first train in 2 hours. And the line segment ON represents the distance covered by the second train in 2 hours. And how do we find distance? Speed into time. So we should write speed into time here, speed into time here. Now it's given that the first train is 35 kilometers per hour faster. This one is faster, so x plus 35. This is the speed. So this is x, speed. And time is 2 hours. Time is 2 hours. So how do you find distance? Speed into time. What is speed? X plus 35. What is time? 2. So what is distance? Multiply. 2 into x plus 35. So it will be 2x plus 70. And here speed is x, time is 2, so 2x. And the equation is 2x the whole square plus this one the whole square is equal to 130 the whole square. What is 130? It's a distance between the two trains after 2 hours, which is NW. Yeah, please work. I think I've made a mistake in marking here, no? First train towards west, but I've taken that as the, let the speed of the first train be marked. Oh, there's a mistake with the diagram here, children. So I'll do it here. Diagram alone, take it from the figure I'm going to draw here. Oh, I've made a lot of mistakes in typing this here. Also, I've written OB, children. Take the question. I'll work the answer for you. Take the question. I'll work it here. All of you must have taken down till here, no? You found? Okay, what's the value of x? I have x is 25. Okay. Online children, if you have not finished writing the content of the slide, take a screenshot. I need to go to the next slide. Did you write 4x squared or you wrote 2x squared? Four x squared and 4x squared is 8x squared. You wrote 16x squared. Oh, this one is 12,000. Got it? Yeah. What are the answers? 25 and 60. Very good. So x is 25, meaning the speed of the second train is 25 kilometers per hour, and the speed of the first train is 25 plus 35, 60 kilometers per hour. You must write that. Don't stop with x. It's a word problem. You must leave your answer. Like you should express your answer in words. Speed of the second train is equal to 25 kilometers per hour. Speed of the first train is equal to 25 plus 35, 60 kilometers per hour. Found your mistake? Okay. What was that? Subtraction, huh? 4,900 and... But some of you got a perfect value for x. No? Normally when we go wrong there, you will not be able to get a perfect value for x. Got it? Finished? Don't finish. Okay. Done, children? Online children completed?
No, I'm going to complete.
Okay. Okay. Done? Okay, please finish it.
Yes, ma'am.
Yeah, this is the next question. Out of a group of swans, 7/2 times the square root of the number are playing on the shore of a tank. Out of a group of swans, 7/2 times the square root of the number square root of the number are playing on the shore of a tank. The two remaining ones are playing with a amorous fight in the water. What is the total number of swans? Okay, so amorous fight is some friendly fight kind of. The two remaining ones are playing with amorous fight in the water. What is the total number of swans? Okay. So let the total number of swans be x. Okay. 7/2 times meaning into times the square root of the number So many are playing on the shore of the tank. It's given there. We're just reading and converting it, converting English to variables and constants. Let the total number of swans be X. Now, 7 by 2 times means into square root of the number. The total number of swans is X. Now, this many swans are playing on the shore of a tank. Okay. The two remaining ones. So there are two remaining. The two remaining ones are playing with amorous fight in the water. So this one, so where are the swans? Some are on the shore of the tank and two are fighting in the water. So these two put together is equal to X, right? Is equal to the total number of swans. So this is the equation. This is the equation. You can start writing. See if my calculation is correct and solve this equation. So if you want to get rid of the square root symbol, you must have that term alone on one side and the remaining terms on the other side. When you want to get rid of the square root symbol, have that term which has that radical sign, the square root symbol on one side, should be alone on one side. Have the remaining terms on the other side. And now when you square on both the sides, you will get rid of the radical sign, that square root sign, you will get rid of that. 7 square is 49. Root x the whole square is x, not x square. X. My equation is right. Yeah. 16. You split the middle term, or did you splitting the middle term? Yeah, what are the numbers? Finish it. Okay. The equation is 4x squared minus 65x. 4x squared minus 65x plus 16 is equal to 0. So the two numbers are minus 64 and minus 1. Minus 64 minus 1 is minus 65. And minus 64 into minus 1 is plus 65. Sorry, is plus 64. The product, sum and product. If you want to split the middle term, sum and product. Sum is what? Minus 65. And the product is 4 into 16, 64. So the two numbers are minus 1 and minus 64. Minus 1 minus 64 is minus 65. And when you multiply minus into minus plus, 1 into 64 is 64. So 4x squared minus x minus 64x plus 16 is equal to 0. X common, 4x minus 1 minus 16, 4x minus into minus plus 1. 4x minus 1, x minus 16 is equal to 0. 4x minus 1 is 0. X is equal to 1 by 4, not possible. X minus 16 is equal to 0. X is equal to 16. Therefore, total number of swans. Total number of swans is equal to 16. All right. All right. Okay. Yeah, we'll just construct the equation for this one and wind up the session for today. Online children, use the emoji, raise your hand. Ritesh, Aniruddhan, Aragamai, Akshada, Kamalika, Niveda, and Srivatsan. Are you there? Srivatsan. Kamalika, okay. Okay, thank you, children. Yeah, let's construct the equation alone for this and wind up the session for today. And that's the question. Frame an equation. The perimeter of a right angled triangle is 70 units. The perimeter of a right angle triangle is 70 units. Let's just call it ABC. So perimeter meaning AB plus BC plus AC is equal to 70. And the hypotenuse is 29 units. So hypotenuse is AC, right? AC is 29. So AB plus BC plus 29 is equal to 70. So we have AB plus BC is equal to 70 minus 29. How much is that? 40, 41, 41. So AB plus BC is 41. All right. What's the length of the hypotenuse? 29. Let me write that, 29. Now what is AB plus BC? 41. So then what is AB? 41 minus BC. Or what is BC? 41 minus AB. Anything you can take. So if you take BC as BC, BC is BC only. BC is BC. Then what is AB? 41 minus BC. Or you can use X also. You can say let BC be X. See, this is one way. I've written AB is equal to 41 minus BC. So let BC be BC. Then what is AB in terms of BC? 41 minus BC. Or you can also use X. You can also use X. You can call somebody as X. So here you can call somebody as X. Okay, if you call this person as X plus BC is equal to 41. So BC is equal to 41 minus X. So who's X? AB is X. Okay, we'll put AB as X. And what is BC? 41 minus X. Okay. So now the equation is using Pythagoras theorem. So X squared plus 41 minus X the whole square is equal to 29 square. You should not leave it like this. You should work and bring the quadratic equation next. And of course, you solve here. It is only to construct the equation. You can also solve it and find the value of X and hence find the legs and the legs. Hypotenuse is given and hence find the legs of the right triangle. Yeah, write down the question alone. You can finish it at home. Just make a note of whatever you want. Write the question and yeah, then you can decide what to do. All right. Taken down? Yeah. All right, children. So that's it for today's session. Thank you. Thank you so much. Good night. Online children can leave the call.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you.